topic that's come up a couple times throughout the workshop already, and we hope that you guys are still really excited about this and ask lots of questions. So we're going to give the panelists each about 5 minutes to introduce themselves. You know, basic, this is who I am and how I got where I am. We're also going to tell you about how they're connected to this topic and give you some thoughts to think about. So they're each going to have some opening remarks, get you all thinking. If you're thinking of questions, because we're going to then spend most of this time in Q&A. So we're hoping for you guys to be participating. But the panelists will also ask each other questions if you guys don't have questions, so participate. And then about 20 minutes before the end, we're going to stop and have them each give concluding remarks, give you guys what you should do next step, their advice on how to get involved in this field and think about this in your work. So next, we'll just go here.
Should I get this microphone thing? Check.
Oh.
No. Check.
Hello.
There we go.
Hello. Okay. Hi, I'm Mike Sturpin, and I'm a PhD candidate at the University of Colorado. Some of my background, I came into grad school interested actually in fairer classroom models, looking at curriculum and how we actually teach STEM. And so my first project was actually trying to make dynamic classrooms using machine learning systems to look at people coding in real time and try to make suggestions to people in the classroom of where they might be making mistakes and things like this. Pretty quickly in my time in grad school, I ended up getting involved after doing machine learning in some deep learning projects, and my background was in philosophy, and years before I came into grad school, I mostly was just doing community work and things, and I got really concerned about how AI and machine learning may actually change a lot of public life in the next coming decade or two. So I ended up taking a lot of my philosophy background and applying that to how I thought machine learning was being used, and both in the industry setting and in the academic setting. And so basically now all my work is on the ethics of these techniques, from data mining, machine learning, or AI, however you want to call it. And then I'm also very interested in public communications. So my main piece for my PhD, I guess, was I wrote a play that was all about the ethics of the use of personal data, in particular, like what's the possibilities with predictive inference, how might people try to get you to do certain things, potentially manipulation effects of knowing so much about people and being able to infer about people. So we wrote this play, and the whole goal of it was to bring together technologists and non-technologists to actually have discussions around the ethics of these things. And it was actually a really, really great experience, and really saw how the public and different communities and different types of people who were in the audience of the play had very, very different perspectives about what was going on, who was winning in the technology revolution of our society. And yes, so these are kind of my two main focuses now, is public communications and ethics. So for this, it was really nice to be asked to come here, and I'm particularly interested in, so the first point I put up here is actually how do we get engineers to be trained to think about multiple points of view? So often we're trained to think about particular kinds of optimizations. How do we create efficiencies in a certain kind of space? How can we gain scientific knowledge that currently no one's gaining from a particular kind of data set? And sometimes if you think about it from a couple different angles, you might see that certain people don't want anybody inferring that kind of information about that, or that certain people can already see utility of a certain kind of inference that's being made, say about health data, or say about crime, or some problem space where the way it's handled in society is not exactly evenly distributed. Not everyone thinks the same way about it. And I think that it's very interesting to see how we could get engineers to be more aware of different framings of problems, and how potentially something that looks like scientific knowledge, that looks like an innovation to one person, might look like a threat to another community, and how do we get people thinking about that. And I put bullet point 2, the fact that computing continues to be very homogeneous in terms of identities that are in computing. I think it really reinforces this first problem that I was just building up, because you have the same kind of people from same kind of backgrounds in the room framing the problems and things like this. So also thus broadening participation, I think, is a really important thing. And then the last thing is I put also, I think, something that amplifies number 1 as well, but potentially has other kinds of effects that are more broad, is the fact that the public just really doesn't understand the kinds of work that we're doing often. They don't know that a piece of data that they're giving actually contains something sensitive that someone could infer. I was just at CVPR, Computer Vision conference, giving a talk, and it was incredible to see what kind of information they could get out of photos of people. And people are completely unaware. One guy presented a survey of people saying, here's information I would willingly disclose, and here's photos I would willingly disclose. And his whole research project was just showing you how your photos you disclose actually disclose all the things you think that you don't want to disclose. So I think that's a real problem, because then once people start seeing how people are using their data or start seeing the effects, it creates a kind of tension between the technology community and the public. So very quickly I'll say, so some of my future goals, or what I would like to see developed, is educational programs for young engineers to actually start helping them think about all these different multiple problem framings, what kinds of problem spaces have certain kind of biases latent in it, or likely biases that you might come across. How do we get people to think about more pluralist problem framing? How do we bring in people from across disciplines or even from outside communities to get us to rethink our problem framings? So that's my number 2 point, is I really would like to see people actually bring in external communities, researchers particularly that are doing data sampling, bring in external communities to talk about what would a fair sample even look like, how can we debate about whether or not I even looked at this problem in the right way. And then finally, 3 is to just basically make efforts to elevate other voices into this entire nexus of decision making and power that we have as computer scientists, because I think, as I said, with the public often not understanding, it creates a very big gap between what we're doing and what we're imposing on society. And I really would love to see more finding intelligent voices that maybe not be in technology, but elevating them and bringing them and trying to create the technical counterpart to what they're saying or what they're criticizing. So anyways, that's some of my initial thoughts. So thanks a lot.
Oh, yes. Thanks, me. Good. Right. So hi, everyone. My name is Bert Houston. I am a PhD candidate at MIT. So my background is in discrete optimization and machine learning and kind of modern computational techniques. And the last couple of years I've been using this to create new types of machine learning models, specifically for applications in healthcare, in criminal justice, and in credit scoring. I guess that all these areas are areas where humans have traditionally made decisions. And so I think, one of the big questions here is like whether or not we should be using a predictive model at all. In some cases, this is actually like required by law. So for instance, a lot of states in the US now require a sentencing tool. For instance, even if you don't actually require a model, there are like other things that need to be addressed from a predictive model. So for instance, like the Fair Credit Reporting Act requires that if you're using a predictive model to approve or deny credit, that when you deny credit, you have to give a reason for that denial. So within this kind of broad area, these are like really important applications. There are legal requirements for predictive models. And I think that it's just really hard for people to create these types of models. Usually, I think that machine learning researchers focus on one small part of the problem. When you're working with models in this area, they have to not only be like accurate and fair, but they also have to be interpretable. They have to be aligned with domain expertise, because if they're not, then people aren't going to use or accept them. And so, what ends up happening is that a practitioner ends up combining several methods together and creating this kind of ad hoc pipeline. And at the end of the day, it's very hard to create a good model and to say something like, hey, this is the best model I can create. And I think that's something that's really important, especially if you're developing a tool for sentencing or credit screening, because, it's lives are at stake. Yeah, I guess in terms of kind of future goals, like what I'd like to do is, for practitioners, I really want to work on methods and software to make their lives easier. And I think this can be done by creating methods that allow people to customize their models and that give like really useful guarantees. So something like, not necessarily that this is a model that performs well, but this is the best linear model. So that's like a very powerful guarantee. Another thing I think is for the general public, I think has to just generally be aware of the issues that can go on from a methodological perspective. And I think that just in general, I'd be really excited about working on like legal standards regarding like the deployment and development of machine learning models. So like now, for instance, you have a lot of areas where there are like legal requirements of interpretability for a machine learning model. Like the FCRA is the good example.
And what does that stand for?
Oh, the Fair Credit Reporting Act. Yeah, Fair Credit Reporting Act. But it's just what exactly is the reason, right? Like, is a variable important to plot for random forest like a good reason or not? And so I think just generally educating people on what are good reasons, what are not good reasons, what are limitations of certain techniques is kind of a valuable thing that we can do. And lastly, I think I want to work on kind of community building for fairness, accountability, transparency in machine learning. I think that it's important for machine learning researchers to have like a safe space to come and discuss their ideas and present their work to get other people interested in these problems. Yeah.
Is it me?
Yeah.
How did you know? Remembering. You must have looked carefully at the slides.
Hi, I'm Christiane Lum. I am the lead statistician at the Human Rights Data Analysis Group. We are a very tiny nonprofit, and we specialize in quantitative methods to address human rights issues. Right now, I'm working on human rights issues in the United States, which is a bit of a departure from us from our historical emphasis on international conflicts and casualty estimation in those settings. And in the US, I'm interested in policing and criminal justice in particular. So that seems a little bit different than my training, which is up here, which is I did my PhD in statistics at Duke, and it was a while ago, back in 2010. And since then, my career or my sort of research interests have taken a little bit of a turn, because back then, the slide asked us what our training was, and this, I use these things all the time, but I'm not doing a ton of research directly into the methods anymore. A little bit, but not as much as I used to. So my training was originally in Bayesian statistics. That's what Duke emphasizes. And by that, I'm sort of statistical modeling and computation. So how do you design a new model or new method, and how do you estimate that? In the setting I was doing it in, it was how do you come up with an MC algorithm or something like that to estimate a model that you think fits sort of the scientific hypothesis you want to test, or the sort of structure that the scientists you're working with say, their understanding of the problem follows. And at HRDAG, I've worked primarily on population estimation, so in that setting I have worked on methodological development, where population estimation is estimating the number of things in a population, where things in this case is the number of casualties in various conflicts, but it usually, in most cases, it's something like number of cases of disease or number of animals in a population. And so the next thing we were asked to address was our connection, so why we think we're here. Mine's a little different than the other ones. I actually just put something I did last year, which was demonstrated how a machine learning-based predictive policing algorithm could lead to targeting of historically over-policed communities, and unintentionally create feedback loops where the algorithm will become increasingly confident that even though it's not necessarily going to the right place, that it is. The feedback loop would rise, because if police are deployed to the places that are historically overpoliced, they're being deployed there for exactly that reason. Then they get there, they collect more data, that gets fed into the algorithm, sort of reinforcing a feedback loop. So I think that's why I'm here. Also, just because I work in this area in general, like some of the other people have mentioned, I'm part of this FAT ML community. And so, yeah, I guess that's probably why I'm here. All right. So the ethical concerns I have for machine learning, this is actually sort of one concern divided up into 3 parts, but this is sort of the heart of what I talk about all the time. And so I'll just go through this really quickly, is that data is often produced as a result of decisions made by humans who are susceptible to bias, and that bias is encoded in the data. So for example, in the settings I'm thinking about lately in policing and criminal justice, you know, a lot of the data sets will include some measure of rearrest. And what they're trying to measure is reoffense. Now the whole point of these models is that they would like to remove sorts of human bias from the system. You know, there's a lot of discussion about, in particular, racial bias in policing and criminal justice. And so the idea behind these models is typically that we'd like to remove that. However, if you think the system exhibits these properties, then the data collection will also embed those properties or encode that sort of bias directly in the data. In particular, if there are certain communities that are arrested at a higher rate for a constant level of criminality, those sort of disparities will be encoded in the data. And so that's one example of how that could happen. So then point 2 on this, really this is all 1A, that was I guess 1B now, is that if you then use any sort of machine learning, you can call it some sort of statistical model, what else am I missing, AI, any of these things, right? And you train it on that sort of data, those models will inherit that same bias. It can be very fancy, it can be very black box, you know, it can be something that seems like it must be objective, but if the data itself is collected in a way that's subject to bias, then those same biases will be encoded in that data. And then when you make predictions using your model, which is typically the objective of fitting the model in the first place, those predictions will also reflect that same bias and potentially having large societal consequences. So the thing I'm thinking about is predictive policing in this case, or also these risk assessment models that we just discussed a second ago. And so this one's maybe my own opinion here, but I think this happens because the people who are building the models aren't thinking that carefully about the provenance of the data. So they're not thinking about the role human discretion or non-representative sampling plays in its collection. So when I say non-representative sampling, I just mean not everybody has it, not every thing in the population, or in the case I'm talking about, it's like a thing would be crime, has the same probability of being recorded or observed. And I'm using non-representative here. And actually something I want to bring up is that in statistics we'll often call this bias data. But there's this sort of confusion because we hear bias and we think of how I was using the word biased earlier, you know, biased policing, biased criminal justice system. But there's also this technical term which just means not every ball in the bag is the same, you know, probability of being drawn out of that bag. And so I think this creates this disconnect between sort of the people who are working in statistics and probably machine learning also, and people who are talking about biases. In this very specific case where we have this collision of terminology between sort of the technical terminology and the everyday terminology. So I just wanted to be clear on that, but because I might use later today, I might use the word biased data set, and I actually might mean not representative, but just wanted to put that out there. All right. And so, future goals. So right now I'm working with a lot of public defenders and lawyer organizations to help them understand some of the issues surrounding risk assessment models and predictive policing. So my first goal, these are my personal goals rather than goals for the community, which it seems like other people are addressing a little bit more, but my personal goals are to help the people who are using the models and people who are being judged by the models, the people who are representing people being judged by these models, to understand what's going on in these cases and think very carefully about the issues I just talked about, and also to develop statistical methodology to support the creation of risk assessment models. If we're going that direction, I'm not going to stand in front of a moving train, and so like I'll try to push this mass moving train, I guess, in a direction that I think makes more sense. So develop statistical methodology that comports with a variety of notions of fairness, which I'm sure is something we'll talk later because I know everyone has, that's the obvious go-to question in this case, I think. And also, since one of the benefits of going after other people is I'm going to sort of copy off of some other people to also reach out to other communities, in particular the statistics community, because I think that a lot of the work in fairness in these areas has been done by computer scientists and machine learners, and I think statisticians ought to have a lot to say about this, and so goal 3 that's not on the slide.
Thanks. Hi everyone, Solon Brokus. I am a very recently started professor at Cornell in the Information Science Department. Actually, like Mike, I have a background sort of in philosophy. I got my PhD at NYU a few years ago working with a woman named Helen Nissenbaum, who does sort of applied ethics of technology. And so I'm sort of trained in thinking about normative and policy and ethical issues related to technology. And while I was going through my PhD, I did a fair amount of coursework in data mining, specifically with Foster Provost, who is a pretty long-standing figure in the KDD community. And so I ended up doing my dissertation that was sort of like very much looking into the technical details about how data mining works to try to draw out some of these ethical issues. And in particular, although I did a lot of work related to privacy, the thing that really preoccupied me and what I spent the bulk of my dissertation writing about were questions of discrimination and fairness in machine learning. And shortly after I graduated, I actually started this workshop that's been mentioned a few times called Fairness, Accountability, and Transparency in Machine Learning. I started it with Moritz Hart, who is now a professor at Berkeley, and it was originally at NIPS, actually in Montreal a couple years ago. And there'll be the fourth version of the workshop here at KDD tomorrow. So if you folks are interested in this, I definitely encourage you to stop by. My own sort of approach to this is to draw on lots of these techniques from sort of the philosophical and social sciences, from philosophy and social sciences, thinking about these questions. And there's this very particular tradition called values in design, which is sort of trying to tease out what are the normative commitments and values that people actually inscribe in the tools that they build. And this was a particularly interesting question when we learn decision procedures from data. And so I've been trying to sort of port some of those ways of doing things to this area of machine learning. And in particular, the work that really led me down this path was this article that I co-authored with a legal scholar where we kind of like surveyed the many different ways that machine learning and data mining is vulnerable to inheriting all sorts of biases, and then the way that the law actually would think about cases that involve those kinds of problems. And so I'll just quickly talk about a few of them, although they've already been mentioned for the most part. So for instance, Christiana was talking about the fact that we can have skewed, in this sense, statistically biased samples, and that can produce a feedback. Oh, sorry. I'm clicking on my phone when in fact I should be clicking on it. Thanks. Sorry about that. So I kind of complemented that though as a slightly different problem, which is that in many cases, even if we have a representative sample of the population, it might well be that a minority population is just sufficiently small in comparison to a majority population that you'll have fewer examples to draw from. And generally speaking, the accuracy of our predictions depends on the number of examples we have. And so just by virtue of that being a minority population, we might have models that are less accurate in making predictions about that population. And this would be specifically true if the kind of patterns which apply for the minority population are different than the patterns that apply for the majority population. So for instance, if this is a standard example actually that Moritz makes, and Cynthia Dwork, in fact, who's giving an entire keynote, I think, on fairness later this week. If, for instance, SAT scores are good predictors for a certain part of the population, that might mean that it does a great job of predicting college performance for some people, but much less well for the minority population. And it may well be that other indicators are reliable predictors of performance for the minority population, but because we don't necessarily have that information, or we don't even have access to the fact that someone belongs to one of these different populations, our models just might do much less good for the minority population. In the interest of time, I'll skip this first point, but another point that's interesting is sort of the fact that these decisions, the examples we rely on could just encode past discrimination in the sense that if, for instance, I want to build a model to predict who will be a high-performing employee, I might just rely on the annual reviews that people in the past have received and try to figure out what are those features which best predict who will go on to receive a good annual review score, right? However, if people were actually assessed prejudicially, or there was some kind of implicit bias that affected the ways that humans were scoring people in the past, that means that these models are going to be given data that they don't realize are necessarily biased. And so what they're learning to predict isn't the true performance of people. They're learning to predict what label a human would give that person, given the fact that the people themselves might be prejudicial or biased, right? And so in a way, the training data itself encodes these kinds of prejudices and biases, and there's no particular way for the model to know this. And what's even more, I think, worrisome here is that even our validation would mislead us, right? Because the validation would say, this is a great prediction, when in fact, like, it's a failure to recognize that the original label that we're giving to the examples was wrong. Right? And then there's another possibility, which is a much more tricky situation, which is that there are going to be many situations where the features which reliably predict some outcome also end up being highly correlated with what the law calls protected characteristics, meaning your race, your gender, your disability status, your sexual orientation, and so on. And in many situations of pretty significant consequence, it's not terribly uncommon that that's the case. So thinking of things like credit, or even recidivism prediction, and things like that. And the question there is, how highly correlated must things be for it to become, seemingly unacceptable to rely on that as a way of making the decision? And a lot of the work that's been done on fairness in machine learning has sort of been grappling with this problem as well, right? So we want to make it possible to make accurate predictions, while at the same time, we don't want those predictions to sort of indirectly become ways to reproduce discrimination by proxy. And I could say a lot more about that, but it's a more complicated issue. And the thing I'll just end with by saying is that, a lot of this, in fact, all of it, is unintentional discrimination. Sort of what Christiana was saying is that this is, I think, mostly the result of inattention or a lack of awareness rather than conscious prejudice. So I don't think people are setting out to build models that actually have these effects. And I think in most cases, if not all, the result is something that people didn't anticipate and weren't actually trained to think about. So you may be trained to think a lot about like robust validation, but you're not necessarily trained to think about how validation fails in ways that are systematic and which end up having these disproportionately negative effects for certain populations. And so I would just re-emphasize the point that Christiana made, which is that there's a lot, I think, that can be gained by just thinking about these problems with this inflection of ethics and sort of fairness in mind as well. And then just in terms of future goals, I want to, thank you, sorry. One too many. Thanks. I'm continuing to work with a number of people, including people here at this table, to build this community that works on these questions of fairness, accountability, and transparency and machine learning. And we're hoping to scale up from a kind of workshop that has been attached to different annual conferences to a larger conference that will draw in people not just from data mining and machine learning, but the broader computer science community. And so we'll have an event in February, actually, a 2-day event in February in New York, that's sort of bringing together the growing community of people who do this kind of work. And likewise, I would hope that some of the folks here consider submitting work or attending. At the same time, this work it's been a very exciting 2 years, I'd say, where a lot of people have begun to work on these issues. There's a significant amount of original research, technical research on these questions, where questions specifically about fairness have become like a first order concern within computer science. But it's also becoming increasingly detached from the policy and legal community, where the work is very hard for people outside computer science to really understand what these contributions are. And so there's a significant, I think, challenge here in trying to figure out how to make what work is being done within computer science intelligible and understandable to the community that's actually best positioned to put it into practice and to make it part of the way we think about solving these problems. And so another thing I think is really important is to cultivate the skills that are necessary to explain what this world is doing to the people who are in a position to sort of push that forward. And the final thing I'll say is that there's also, I think, been a tendency to move toward theory, which is, I think, fundamental at this point, just to establish a lot of important guarantees about what we can do with these kind of techniques. But there's also a significant challenge in actually translating this stuff into practice. And that's true for a number of reasons, not just because of this kind of challenge of explaining things to people, but also there's the practicalities of building a machine learning pipeline and actually having some kind of process that doesn't require totally re-engineering the way you do things. So I would just say that the KDD community in particular seems like a nice place to maybe think about that because it's much more applied than many other settings, many other conferences. So that's the final point I would hope to emphasize. Thanks.
Hey, so my name is Flavio. I'm an assistant professor at Harvard. Before that, I did my PhD in electrical engineering and computer science at MIT. And before joining Harvard, I spent a couple of years as a social good postdoctoral fellow at IBM, where I worked in problems in privacy, problems also in computational creativity, and things involving fairness and data mining and so on. I think I come from a slightly different angle from other people here in the panel because I come from a very, my home community is a very theoretical community. It's a community called information theory. I don't know how many here know what information theory is or heard about it, but basically what we do is that we look at the fundamentals of systems that process, transform, and communicate information. So one of the claim to fames of what this community has done is, for example, understanding the fundamentals of communication systems, how to compress data, and so on. And now there's this push into looking at problems in machine learning and trying to understand what are the fundamental limits of what we can learn from data, particularly noisy data, and what are the trade-offs involved in designing machine learning algorithms and so on. Within this context, I worked a lot in problems in privacy. So before turning more towards fairness, I was looking at questions, for example, how can we distort data in order to hide certain features that we consider private and still have this, and this data still be useful for some kind of classification task. So as a PhD student, I worked with a company called Technicolor, where we developed these mechanisms that do exactly that. Like, for example, how do we distort your movie ratings so we can still give you good recommendations while hiding your political preference or something like that. And when I look at problems in fairness, and I look at it from somewhat of the same perspective, so I ask myself, what are interesting models and interesting frameworks where we can look at these trade-offs involved in fairness and discrimination? I think someone touched on that, like what are the trade-offs involved in accuracy while still providing some kind of parity measure and so on. And how can we translate these models into actual meaningful algorithms and communicate this to practitioners that are working in the field? So that's where I'm coming from. So I think when making this slide, I decided to list two main problems that I'm particularly curious about, and I'm sure others in the FATML community are also looking at. The first one is, what are the fundamental trade-offs in fairness, right? How can we quantify this? So like, if you're trying to change or modify some kind of data science pipeline in order to ensure that the decisions that you're making are fair, or you do not have a disparate impact between different groups, for example, in recidivism or credit approval and so on, what are the trade-offs involved in this process? How can we quantify them? How can we measure them? And in particular, how can we use theory that we develop to understand these trade-offs as a design driver for practical algorithms in this space, right? And how can we take this theory outside of a community of computer scientists and mathematicians and actually translate this to practitioners? So this is one thing I'm particularly curious about. And the other one that is also learnability of fairness and learnability of discrimination, right? I think we live in a world where data is increasingly high dimensional, right? Especially when you're talking about data about minorities, sometimes data is scarce. And what are the limits of when we can detect discrimination? How can we say with statistical confidence where it can be found? And how can we put this and package these mathematical notions in a way that practitioners and legal experts accept them or is in line with the current thinking in this process. So so measuring and mitigating discrimination is something that I'm particularly passionate about, and really using this like fundamental way of thinking of trying to create these new metrics or use existing metrics in real systems and translate this to practitioners. So, and this is the way I come about my research, and this is my future goals in the work that me and my group and I are doing. The first one is use real-world examples in discrimination as a design driver for interesting and meaningful theory that captures the fundamental operational limits of fairness systems or fairness in machine learning, and then use this theory as a design driver for practical algorithms, as I mentioned before. And the other thing that I'm really, I think it's really important, and especially in the computer science and electrical engineering classroom is sometimes missed, is bringing these social good-minded topics, bringing topics of fairness, for example, or privacy and so on, into the classroom. So we make sure that the next generation of machine learning experts that we're training have embedded in their training these concepts and this thought process. Unfortunately, I think a lot of the social discussions surrounding machine learning and surrounding the impact of data mining is sometimes absent from the university classroom, particularly in those technical classes. I mean, like even the data sets we sometimes train our students on are not that meaningful. So how can we flip that around and use research in fairness and algorithmic transparency, research in privacy and so on, as also a driver to inform and educate and create this critical consciousness in the next generation of data scientists and engineers. So, yeah.
All right. So, we got a lot to think about out of the panel so far. People, that moved really easily. So we got a lot to think about. These panels all had different perspectives and different backgrounds, and we have them include their backgrounds, so hopefully you can see how they move from, they all have technical, or half of them have technical backgrounds, some of them have a mixed training, and into this, contributing in this fairness and ethics community. So do you want to open up to questions, or should I get started? You want to start?
So, I think, Christian, in your portion, you mentioned, so you mentioned how people perceive, kind of, I'm changing words, kind of how they perceive uncertainty or the bias inside the model.
Yeah.
So my question is, how do you think we can help educate people to understand the statistics, the underlying statistics behind their decisions, or how can we show them the impact of their decisions through displays? And it's for everybody, but your point particularly.
I'll start. That's
cool.
Yeah, so I guess I don't know that there's like one best way to do this, but maybe I can talk about how I try to do it. So I guess one of the ways I try to do it is through sort of visualizations or actual examples where I ask people to pause it. So in the case of, say, predictive policing or something like that, you know, you can actually have some sort of simulation and you can allow people to fiddle with some toggles, like, okay, how fair do you think the world really is? And then let them change that. Okay, this community is going to be arrested at a rate, you know, X times this other one for a constant level of criminality. Let's say, okay, everybody in this simulated, you know, ideal world has an equal probability of committing a crime. Now let's look at the demographics. Okay, what do you think the arrest patterns would look like even if everybody is truly exactly equal in terms of their probability of crime? And then actually behind the hood, I have this little demo where I'm like, all right, now press go. We're going to actually fit a real machine learning model, you know, sort of build it up, and then let them see what the predictions look like in terms of who is predicted to be high, who is predicted to be low, and then sort of remind them of the setting in which we've done this type of thing where, you know, it is hypothetical, where every single person has exactly the same probability of committing a crime. So I think that's one way to do it, is to, I mean, that's at least my attempt, and it seems to work okay. I mean, I'm still fiddling with the details of how I do this, but I think it's helpful to allow people to try to do those things, you know, and I'll include things like what we were talking about earlier, have some variables in, where, okay, maybe we include a race variable, maybe we include a gender variable, and we have all these other sort of fake variables on that. Okay, what if we take them off? Let them press go again and see what the predictions look like, so they can actually discover for themselves that, oh, we have these proxies that will actually, you know, serve the place of these other ones that we've left out. And so I guess I think that allowing people to sort of interact with these types of things is helpful, because understanding sort of what's going on under the hood takes a lot of background information that, because you guys are here, I assume you have some of that, but, you know, a lot of people, like lawyers, for example, typically don't. And it's important that they understand these issues, and I don't think it's reasonable to expect everybody, you know, to go get an undergrad education in mathematics or something to be able to understand this. And so even if you don't understand how the models are being estimated, you don't know what like the maximum likelihood estimator is, to be able to fiddle with something and see the results yourself, I think is powerful, maybe not quite, maybe a little bit too strong, but I think it's effective. But I mean, I'm interested to hear what other people have to say, because that's sort of my approach.
I just had two ideas. I think one of them is just when you're talking about performance, like going from rates to actual like whole numbers goes like a really long way. Like when you're talking about, you know, like recidivism prediction tools, people talk about like true positive rate and false positive rate, and they're like, oh yeah, this is great. It's like 90-10, beautiful point on the ROC curve. But then you like translate that into like an actual decision, and it turns out that, you know, you're basically, because like the size of the populations are different, you know, I think you could be like falsely convicting thousands of people and maybe only catching like 100. So just being able to like put a sentence in there to say like this is what the actual performance of my tool is, like goes like a really, really long way.
Yeah, I also think like what Brooke mentioned, like also if you're using this to teach like machine learning concepts and so on, make sure that the examples that you're using are relevant. Like one thing is doing some prediction task on the Titanic data set. The other thing is doing it on a recidivism data set, right? And the insights and the concerns involved are very different. And even if you're illustrating like machine learning models 101 to people that are not accustomed to look at that or are new to the field, I think having meaningful examples and meaningful data sets is key.
The other thing that people have suggested, and actually be curious what the other panelists think about this, is just that, we generally report performance in aggregate. So like, overall, this is how things perform, this is how this model performs, but if we actually break it out by population, so for like this, for people with this particular characteristic, this is the performance as compared to another. And even that can be, in cases where that is quite different, that can be quite revealing. And I think it actually shows people that it's really not enough just to think about overall performance, but we need to think about how this differs across population. The other thing I'll just mention quickly too is, I imagine lots of people learn about sort of like explore-exploit or even reinforcement learning and these other methods which are specifically designed to deal with the fact that we're uncertain about the quality of our current model. And if you get people to think, and we learn about that often in like trivial settings like advertising or whatever, but like think about that with the kind of stuff that Cristiano's saying, which is like we actually don't know what the true rate of crime is, and if we just continue to make predictions based on what we're observing rather than what the true rate is, we can get in this feedback loop. And these methods are designed to overcome those problems, but we don't think about them very much in the context of these really high consequence applications. And so I think that's a really easy way, if you're already accustomed to that way of thinking, to get people to realize that like that's actually an issue that's not just about, optimization in these very like narrow settings, but like really profound questions about people's lives. So.
I'll first echo a thing that Flavio said, which is I think finding good data sets to be able to get people to reflect about these things, that both a data set that contains hard and interesting problems, but also contains these very sticky, difficult problems inside of it is really good. But I'll just give an example from a class I taught and how I got some of these things in my, hopefully, students' minds working. So what we did was I had them think about the difference between a construct space, meaning something I want to measure, an observation space, meaning now I have a data set that hopefully gives me some metric or proxy into this thing that I want to measure. So maybe intelligence is my construct and SAT scores or GPA or grades are my observation space. And now I have a decision space, which is I want to actually make some meaningful decision off of this. And so the way I described it to my class was, well, if you have a construct and you're trying to create an observation space, you're making a capture system. You're creating some sort of system to decide what are the events or what are the actual tangible behaviors that allow me to have some insight into this construct. And then to make a decision, I need to design a metric. I need to design something that says, hey, here's what in this observation space, here's how I analyze it to get a meaningful insight out of it. And so the first thing I had them do is I took all their data off of our online courseware and I said, design a metric that should help me decide who to give a scholarship to. And so they came up with some different, in groups, analytic procedures. And what we saw was confirmation bias, that people created procedures to analyze this data that gave them the scholarships, right? And so what I did was I took their different analytic techniques and put it on the data set at home, and then I came back and said, here's who would have won the scholarships if we use this person's technique, and if we use this person's technique. And somehow, surprisingly, you won the scholarship, in your case. And I think it was actually really good at getting them to see that, oh, look, this works for me, and it's also maybe had some valid insights. It's not that these students were doing anything, I think, insidious or crazy, but they obviously think a good student has something to do with what they are. And I think often we're doing this when we come into problem spaces. And so another exercise I had them do in the same thing was I said, okay, let's now take, I had a small Facebook data set that I collected off of people who agreed to be in this. And I said, now take this Facebook data and assign these people a net worth index. So create an index for how likely you think they are to be rich or poor or where they are on the spectrum. And then basically what we did was use this as a way to pick apart how, okay, this is the way you designed your metric was gameable. Some people are presenting themselves differently. The way you created this metric actually had severe biases. You were completely missing certain ways in which people are actually creating social mobility for themselves and stuff. And basically, this obviously takes like someone like me or someone like some of yourselves or on this panel to be in front of the classroom to be able to pick apart these things. But I guess that's just my best answer is this is my example of I tried to apply something like this in the classroom and I actually found it to be very powerful. Students afterwards were like, oh, damn. Like I did not realize how hard this could be or how many different ways. And I think the really important thing was just seeing how their different metrics applied to data sets just created different results. That factor alone, I think, surprised a lot of people of how different the results could vary, even though their justifications and rationales for choosing a metric were reasonable. Anyways, so.
So I think it's open to all of you. Loved the introduction, so really interesting paper, the research. So there's a lot of user data and there's a lot of personalization that's happening, targeted ads. There are things like businesses are trying to customize their websites just to suit if a woman or a male is visiting the website. Inferring political polarizations from social media. And I'm just wondering about most of the time the way we justify or we talk about this is essentially to improve the customer experience or to sort of help the political campaign. So I'm just interested in understanding like what's your take on that. And the follow-up question on that is, I guess as a community, especially with deep learning, I guess coming into the picture, we've talked about this I think yesterday briefly, but we're heading more and more towards using embeddings and using latent space for getting these predictions. So I know some of you touched upon that it's important to explain your results. So I'm just curious as to understand how do you see the field sort of merging with one side where you're using the latent space and on the other side the methods are sort of becoming more convoluted. So yeah, I would love to hear your take on that. Thank you.
Yeah, this is a great question. I think that in particular with the deep learning boom, it's particularly pertinent because inspecting these things globally is nearly impossible at this point. And so I guess I'll just say at a high level, I think that this tension that you're talking about, which is really difficult, comes down to the fact that obviously people are giving data, whether it's public data or whether it's received through private channel, and ultimately, one way or another, we're creating inferences to pull out information that wasn't disclosed actively by the person who gave the data. And that obviously is what we think of as to some extent the power of science, right? I mean, we can do these things like find latent variables that are not in the data set, and that's a very powerful thing potentially if we're trying to, say, figure out what an ideal policy would be for, say, potentially like how to create, we could imagine how to create fair housing or something. We might imagine that what's currently in a housing application or what's currently being used to decide that isn't the fairest system, and we might be able to discover something, So I think there's some really powerful things to that, so I want to make sure I premise that first because I don't want to completely discount this. But on the flip side of this, I am really concerned about what sort of foundation we're laying in terms of trust with people when we are basically plowing forward with this idea of you give us some amount of data and then because of aggregation and the way that we can do predictive inference once we have lots of data, we can now pull out categories that maybe you never even intended or maybe categories about you that you didn't even know you fit into. And I think that ultimately that leads to potentially treatment of individuals once these things are in the wild, once these models are out there actually doing something meaningful in people's lives. Now they're having decisions made about them, about things that they're not even aware of. And to me, this is a potentially disturbing problem because, I think we all have some idea of fair recourse of if someone makes a decision about us that's in an unfair light, we would like to be able to say, hey, we think that's unfair, I want to reproach this, I want to take this to court or whatever. And suddenly when we have no idea what actual information was used or what the actual meaning of that information is, I think we start losing an intuition around what was fair. You know, was this actually a fair decision? And maybe you tell me what data you used, but I have no idea what could be inferred from that kind of data, and I start worrying about whether or not people can maintain this moral intuition around fairness, and whether then we even know when we should have recourse or not. So I think that, like, to finish this up, a convergent space of these two communities, the one that's going after transparency and the other one that's using more embeddings and figuring out latent variables and things, I think that potentially there needs to be some kind of, I believe at least, movement towards what is a fair auditing of these systems, meaning how can we create a way for people who want to find out how decisions were made about them to find out potentially what these latent characteristics that were pulled out were. So I think that, like, ultimately, if we're going to keep going this way of, like, non-interpretability and having these very complex deep learning systems, while we have this other community trying to push for transparency, it's not clear they're just going to kind of come together. So I think, like, a push towards, well, at the very least, give me an auditing procedure so that I can make sense of maybe what your system was thinking or trying to do, and then people can potentially do translation work on these kinds of audits of these systems, so that transparency community can kind of come in and say, okay, your machine learning technique isn't fully transparent, but, you know, if we create a standard of, but give me, you know, a report that audits and tells me what all you did, then hopefully these technicians who really care about transparency can do some of that translation work to kind of keep a space open for people to reflect on these kinds of decisions. So
I know other people, especially Bert, will have a lot to say about explanation and deep learning, so I'll let him handle that one. But the question about, you know, like what to do, what should we think about targeted advertising specifically when it comes to things like political ads or political campaigns? And I mean, this is maybe like a pretty blunt answer, but I think, like, fundamentally there should be sort of decisions you're willing to make about what type of work you want to do, right? And so I think the earlier panel had it seemed to focus a lot on career choices, and, like, I think this is actually part of what it means to make a career choice, right? I mean, there's this line from Jeff Hammerbacher from years ago, basically saying, like, you know, we don't really want to have, like, all data scientists figuring out who's going to click on ads. We want to encourage people to, like, go and work on meaningful problems. And, you know, I don't want to suggest that people who work on, like, marketing are not doing good work, but there's also a question about, like, what kinds of things you want to apply your talents to. And if you feel that the kinds of things that you're being asked to do can have these pernicious effects, even if it's not your own goal, I think it should give you pause and make you question, like, what you're actually working on. And I think in many ways, like, we often talk about, like, the ethics of doing this stuff, but, like, part of that discussion has to also just be about, like, what type of work are you going to do, right? We don't have the discussion often enough, I think, even though I think it's probably pretty fundamental. But just the other thing I'll say very quickly is that, sort of building on what Mike said, I think the challenge here is that, like, sometimes we're not even inferring some particular attribute in order to then make a decision. We're just trying to, like, make predictions about the likely behavior of someone. So, for instance, it might be that, like, you're just trying to model who's going to click on an ad. And it may well be that, like, in the process of developing that model, it has learned all these things in a latent way. But, like, you have no idea that your model has learned that there's different kinds of political views. It's just learned that, like, these particular features best predict click-through, right? And that can be an especially tricky thing to think about, right? Because sort of without your knowledge, totally unintentionally, you have built a very powerful model to predict who is going to be, like, most excited to click on something that really taps into something, you know, quite, that they find, like, you know, a deeply felt position. And what to do there in terms of transparency is much less obvious to me, right? Like, you're not going to communicate to them, like, the latent variable or any of that kind of stuff. Like, I think what we care, and it even seems to me, like, silly to suggest that the way to handle this is transparency with respect to the user. I think what we want is something like a view into what that targeting looks like across the board. We want to see, like, what kinds of ads are campaigns running, right? Who are the people who are actually being targeted with these messages? So that, like, in aggregate, overall, we can actually say something about this. And the people who are in the best position to do that are the people doing this targeting, right? It's not like we have a way for somebody to easily collect that information from the outside. There aren't going to be regulations that like compel disclosure of advertising by the government's not going to pass those regulations, especially with political ads. So I think like the people who are often in the best position to do that kind of work are practitioners, like are the people who are doing this. And so if you find yourself in the position of actually working on this kind of stuff, one very straightforward thing to do is to say like, what is the distribution of like the kinds of ads we're running, and can we say something about the type of users that are being targeted by different ads? And I think that is way more powerful than expecting that individual users can be given some explanation that allows them to do something about it.
Yeah, I'll actually build on what Solon just said. So the first thing is, I think you have to keep in mind what is the individual level consequence of the output of your machine learning algorithm, right? Because, for example, targeted advertisement, what is the individual level consequence of that? Oh, maybe it'll slightly bias someone towards clicking on an advertisement, or maybe it might change a vote, you know? And I think this is something that at least, and I talk about my personal experience, when you're working in a company and you're under a project deadline and you have to deliver to a client, maybe you just don't think about that. You know, you're just, oh, I'm really happy that I got my job in this big name company and I'm just going to implement my model and make my project manager happy. But I think that's an important thing to keep in the back of your mind. And the question regarding interpretability of models, and as we move, especially with massive data sets, towards settings where you're looking more at feature engineering versus actually building a model that we can interpret and using things like deep learning and so on. I think another angle that sometimes is neglected is the aspect of how you train your model and basically the incentives in training in a way like how you adjust your cost function. I think that would be the most technical way of seeing it. Like usually you look at all of these papers and it's all about squeezing another 0.5% performance or accuracy in this huge data set and so on. How can we embed in these processes other constraints that we want from these models? And maybe in some situation that could even, I don't want to say it begets interpretability, but it could serve as a good proxy for that. But overall, it's a very difficult question. But I guess my observation on that is both working in industry and in academia is that you rarely see this incentive alignment when you're training your model, so you know that your model somehow is fair or guarantees that certain information cannot be inferred while still providing a certain level of accuracy.
I think just really quickly, I'm going to touch on your second question about interpretability. I think that there is concern when you're using kind of like black box, convoluted models for applications where humans have traditionally made decisions. I think there's no real huge reason for alarm because people are actually very good gatekeepers. So for instance, like the EU, there is going to be a law that's coming up soon that says you need to give a reason for any prediction, any machine like produced prediction that affects a human. And I think that similar laws will be coming out as well. And then the other thing I think is, I mean, in these areas that I'm working in, like medicine, criminal justice, like people don't accept black box models from the get-go. They want a model that they can see in front of them. And on top of that, they want a model that kind of works the same way that they think the system works. So you've just got to align to my expertise. So they've got kind of a high threshold for using a predictive model in the first place. And then the last thing is another thing that they want is the ability to override the model if possible. So for instance, like that's why like a lot of sentencing tools are like simple scoring systems is because like a judge wants to be able to compute like a risk of recidivism, but then also like say like, oh, well, in this case, it's not what it says it is. So in that sense, I think that we're safe. In terms of, I think, neural nets understanding them, I don't think that we're ever really going to be able to understand like neural nets. I think that there's good work that's being done in terms of creating diagnostics that helps understand like what features are important, or that like for instance can like extract like a little linear model to like explain how a neural net works. The issue there is that when you're extracting a little linear model, it's like an approximation. If it was like so it's only going to explain like 90% of how the system works, and that remaining 10% might be important. There might be like something that's going on that's funny that is like discriminating or something like that. It's worth saying like if there was a linear model that could approximate the system perfectly, then yeah, that means that like you could learn a linear model in the first place. You wouldn't need like a neural net. So, yeah.
Thanks. Right, so I guess my take on this is that the ethics and concerns you might have are going to be very context specific, and I know that's what you were saying, kind of, but I think we shouldn't forget that you know, if you're designing an algorithm to, you know, when someone shows up at the REI website, what to return to them if they type in shoes or something, the consequences are very different than if you're designing something that will inform a judge about whether someone should receive pretrial release or have bail set or something like that, right? These are really very, very different situations, and so I don't think there is a one-size-fits-all answer both to your question and sort of more broadly to how we should be developing models and which notions of fairness pertain to which questions. I think this is ultimately kind of always going to be very context specific, and so there is a lot of responsibility in the practitioners to think very carefully about the very specific context in which they're building a model and making predictions. And so as I was sitting here, I was thinking of a few things one could think about. I mean, these aren't very well thought out. I'm kind of talking on the top of my head here, but I think, you know, some distinctions I'd make is the system opt-in or not? So in the cases that I think about a lot in the criminal justice system, it's not really opt-in when you're being, you know, when you're at your arraignment. You didn't opt into being arrested necessarily. So, but whereas, you know, I'm sort of going back to this simple example, I show up on the REI website, I kind of opted into that scenario. So I think that's one important thing to consider when thinking about the consequences. Another thing, just to go back to my very pet issue, is the thing you're trying to predict, or any of the things you're using to predict that thing, how did you measure it, and is the measurement subject to discretion? So again, if we're talking about maximizing click-through rate, maybe you don't actually care what you're measuring, but is there human discretion how you record it? Like, is there anybody saying, okay, we will record this click, we won't record this click, we will record this mouse movement or whatever? And in a lot of the cases where I'm not so concerned, that's not so much of an issue, but in these cases that I think have really profound societal consequences, that is something that you have to take into consideration. And of course the stakes, which I think everybody else has addressed. And I don't want to be the person to talk the longest on this, but this, I think, goes over not only into sort of thinking about the data and thinking about the model collection, but also the things like Sloan was saying earlier with reinforcement learning. Even something like this, that specific, I think you have to think very carefully about. So for the example, when we're talking about marketing, so this is essentially something where you don't always do the optimal thing because you want to learn something else. So you could always, you know, serve someone the best ad or whatever, but sometimes you're going to do something a little bit different to learn if you're not doing the best thing. And so, yeah, and in some situations that's going to work great, but in other situations, again, even when you're sort of at this deeper level and sort of our inception thing of, you know, bias, right? That might be a good idea in those cases, but what if we are talking about, not to go back to my pet example, but policing, right? You'd say, okay, maybe we'll deploy police to this other area instead of where our model says this suboptimal location. Well, even if they go to that place, they still don't have the same, even for the same level of criminality, right? Not everyone's equally likely to be observed. So you can fool yourself into thinking that you know, you're solving the problem if you sort of reverse the step and say, okay, well, you know, maybe that's true. Maybe not everyone has the same probability of being observed. Now, okay, we'll go to this suboptimal place and we'll send the police in every person's home and search it. And now we're dealing with like extremely difficult, you know, legal consequences, like things you can't do. So, you know, we can develop this theory that's, you know, works for these sort of marketing situations or these click-through rate situations, but then when you try to transfer them over to these other contexts, well, you have all these other constraints that you have to deal with that you didn't have to before. Like, you can't just send someone to search someone's home without full cause, right? And so, yeah, that was sort of a tangent, and obviously I just went in the direction of something I wanted to say earlier, so sorry about that.
Okay, can I ask a question back on the panel real fast on that? I don't know.
Yeah, go ahead.
Okay, I just wanted to quickly, because I think this is a really, really great question. Obviously, it got some stuff, and I don't want to take up too much time. Maybe panelists can just quickly. Do we think that aligning the values that the users are trying to get from these systems with these kinds of optimizations, like say click-through rate, you know, a really great example I had heard about this was, you know, with the recent election, that we were optimizing for clicking on news articles, and it turned out outraging people who felt outraged at what they were looking at. That was an optimization, but we weren't optimizing for outrage, we were optimizing for click-through. But what if we had potentially created the system to optimize for changing my perspective, and I said, oh hey, this article changed my perspective, and we started optimizing for this kind of thing, that would have been like an alignment towards what the user wanted. So now we're pulling out latent features, but towards something that's potentially beneficial for the user, not for the manufacturer, the people making it. And so I asked this because I wonder if making tools that are specifically for users say, what's my recidivism rate, and here's my social media content. Could you tell me what the likelihood I'd be identified as a likely criminal is, or that I'm likely for heart disease or something? You know, I just think about all these things that researchers are doing to try to extract these kind of features from data, and I'm just curious if we would be a little less in this like sticky place if it wasn't always just us optimizing things that pull out stuff we can't even interpret, but instead creating tools that can help people reflect on their data and what actually is being pulled out of it. What categories am I in? You know, so basically kind of a different engineering approach. I mean, this is maybe a kind of a strange question, but I hope you guys understand what I'm getting at here, which is just more user-centric tools. Would that change Asta's very important question here if we were actually thinking about, rather than tools that hide the variables from the people and just give them a result, what if we were creating tools that like make more salient these things to people? Anyways, I don't know if anyone has any follow-up. I don't want to take up too much time.
I'll say two things really quickly. So I think, you know, people who are trying to like model, or satisfaction is a target variable. Like satisfaction has to be formalized in some way. It's often formalized in ways that depend on what are easily observable, like outcomes. And so people are obsessed with trying to figure out different ways of doing this. But generally speaking, like we end up being very constrained by what we can observe. And so like click-through becomes like the main thing. You know, like a good example of this though is how Facebook has like continued to try to think about what they're trying to optimize for with a newsfeed, and they've definitely changed things because they're trying to get a bit better, like more nuanced notion of satisfaction. But even there, it's difficult because like, do we mean like immediate satisfaction? Do we mean like long-term sense of like, you know, being edified and gratified? And I think these are just things that are happening often in closed doors. Like these companies are not very disclosive about those decisions. And I think it would be really beneficial if this really important debate around what we're trying to optimize for becomes like a broader thing that people, this community can explain to the people who are affected. And the other thing I'll just say is that like that might prompt accusations of paternalism, like, oh, like why are you trying to like make my newsfeed more diverse? Why are you trying to like expose me to competing ideas, right? Who are you to decide? And I'll just say that like, you are already deciding, right? Like just because your notion is somehow not explicitly about these things, like your formalization is already paternalistic and invariably, right? Because you've chosen some particular thing to optimize for. So I don't think we should let people get away with the idea that they're not engaged in this kind of activity, and we should just make it a much more explicit conversation.
Yeah, I think I'll answer the question with a question. So I think my question is, should empowering the user to understand or somehow interpret why am I seeing these news articles, why am I seeing these advertisements and so on, is it a feature or is it a product in itself, right? Is this something that companies have an incentive to add it as a feature? For example, Facebook has an incentive to add a diversity feature in their newsfeed, and you're going to see different opinions that you don't usually click on, or is this something that should come from, I don't know, a startup that creates this product? And if there is a startup that would create this product, would this product sell realistically? And what are the incentives for them to develop that? And I think I ask this question because this is something that because I find these questions very important and I find them very socially relevant. But oftentimes, looking at companies and looking at even individuals that want to go startup in this area, usually this fades away because there's not an economic incentive, or there's not this clear either monetary reward or some other kind of reward that they would get from this work, besides maybe papers and interesting case studies. So yeah, I think that's my question based on that. So I think it's a very, there's definitely a lot of space for that, but would it be a feature in that sense? Is it top down? Or is it a product itself? Would it come from a group of researchers or a new startup that does that?
Yeah, I think your question. I mean, I would say that it really like highlights, I think, the importance of having simple prediction models. When you have simple prediction models, people can use them and see what their risk of, you know, what is their recidivism rate or what is their diagnosis rate. Like they're able to understand how the system is like producing that. And I think that's like a really powerful tool because all of a sudden the tool is accountable not just to you, but to a much wider population. So yeah, I think it's like an important, possibly like requirement for predictive models that are widely used.
So Sloan basically scooped me on the first part of, so thanks. So I'll just echo what he said, that I think predictions will be made on what's available. So the data that you have is what people are going to be using to make their predictions. And so I love this idea of, you know, having some sort of thing where you know, suggest something or you optimize on something. Oh, this changed my opinion, but even getting access to like changing someone's opinion, I think you have to have some sort of crazy buy-in or people are going to.
Data.
Yeah, so that's, I mean, I love the idea. I think it would be very, very difficult because people just are going to use the data that's available. So thank you for saying that originally. And so like Flavio answered with a question, I'm going to answer with an example then of people using the data that's available, and going back to my sort of favorite cases, criminal justice examples, where before I was talking about using rearrest as the outcome. And I've asked a few times, you know, why do we use this? And I've heard at least anecdotally that it's been discussed to use reconviction instead because there's at least this extra layer of protection where you've gone through the system. And anecdotally, I don't have, you know, concrete evidence of this, but I've heard that the reason they use rearrest is because the data is easier to come by and it's cleaner, and the court system data is so messy that it's hard to even figure out and follow someone through their whole case to figure out if they were convicted in the end or not, and match that with the data you need to make these type of prediction tools. And so even when people are aware that there are issues with the data that they're using, they do kind of, you know, revert to these, they revert to sort of the obvious thing to do. It's like, okay, well, we have this data, let's just use this. And so, obviously that's a problem, and I think that's a great question. Yeah.
And I also set this up, so if you ask questions online, then I'll see them and I can help moderate and make sure that people have similar questions, we get them all out.
Okay, well, hopefully this isn't redundant to Michael's point, but a lot of the conversation that we're having right now is very outcomes focused. So we're talking about things like algorithmic bias. We're talking about things like the sort of ethical implications of the results of your algorithm. But socially responsible research really starts with the relationship between the researcher and the research subject, right? So I'm kind of wondering whether there is a dialogue or a conversation happening within this sort of machine learning community that's sort of using this, I guess call it everyday surveillance data that is inherently social data. These are data from people, whether there's a conversation about what this sort of relationship between the researcher and the research subject should be. Full disclosure, I'm a sociologist, so we have very strict human subjects research standards, and we're sort of, those of us who are using like digital trace data, for example, data from places like Twitter and Facebook, are asking ourselves these questions like, I'm using data from people, they don't really know it, they don't really sort of have the opportunity to engage in informed consent the way they traditionally would in social research settings. So what is this new relationship? How do we negotiate this contract? So I'm wondering if this conversation is going on.
Or you can start having it here.
Yeah.
I actually don't know. I'm curious. So other people, I would, if I were going to, you know, collect data myself, I'd rely probably on some sort of IRB or something like that. And I don't know where they fall in this right now, because typically I use data that other people have already collected and have done similar things. And so that's not something I have a lot of experience in. So if other people up here know, that'd be great.
I'm sorry, or if you, I think you raised your hand also.
No, it's okay.
No, you should,
Yeah,
I think you should,
He
no,
has
go
a
ahead.
queue, so.
Oh.
I was
If you have a
gonna
comment
say-
on this, you should definitely chime in.
Yeah, I was gonna say, I mean, I think that's exactly, this idea that you train people on data sets that have no provenance is crazy.
Yeah.
That mic's not on anyways, so. it doesn't matter.
Yeah, so, I mean, because as a, you know, having been on the data collection side as a geneticist and then now being on the data science side, the first thing that we do is say, here are the assumptions that we have in the data, the way that we collected the data, and therefore our models have to be informed by the limitations of what we think the data can actually infer. And so the fact that data scientists get data with no provenance, and they're like, let's go, let's try to do everything, and you know, and then whatever sticks to the wall is what gets published, is very scary from a data collecting side, and even from a HIPAA side, because the implications are vast, as you guys have pointed out, but the responsibility is not commensurate with the implications that are being put out there. So you can put out, well, blacks are much more likely to do this, or women are more likely to do this, and there's almost no responsibility besides like a shame bell, right, for those kind of inference. And it's almost left to communities of color or communities of women and those people who are most alienated from society to then ring the bell and say, hey, let's pull this back in and think about sort of what are the underlying biases and the provenance of this data, which is, I think, deeply unfortunate.
Yeah, I mean, I'll just add to that and say that there's a sort of unfortunate dynamic where computer science in particular really hasn't, even as it's become more focused on social data, hasn't really imported a lot of the lessons and sort of norms of the social sciences, right? Where there's like a profound attention to like the way the data was collected and all sorts of stipulations about how it should be used and things like that. And beyond that, like, I would say that even when computer scientists are collecting new data, like scraping data, it's very rare that they'll actually go to the IRB. They barely even know IRBs exist in many cases, right?
Yeah.
So I think there's just a lot to be learned from the social sciences, and to the extent that more social scientists are getting involved in this community, or that the kind of broader data mining community begins to draw on methods from there, we can hopefully get a lot out of that. But I think a lot more work has to be done to achieve that, and that involves like not just expecting that social scientists will do the work of informing this community, but that people in this community recognize that they actually need to learn from other communities. But the other point you made is one I've also thought about, which is sort of like, are people aware that their data is being used to train these models and so on? And I think the normal approach to that question is sort of like, do people opt into this research project? And I think that's like a very important question, but there's a second question which troubles me even more, which is that sort of along this line of like, the data that's easily available is the data we're using to build every kind of model, right? If you think about it, like social media data is used, or increasingly like images and other kind of unstructured data because of deep learning, is being used for everything, right? Like, I'm gonna infer your health status, I'm gonna infer your mental health status, I'm gonna infer like your likelihood to have this kind of thing happen to you. And we're not doing it using what social scientists would say are like the more obvious indicators. We're just trying to find out that incidentally, the things we're able to observe easily end up being sufficiently robust to predict this kind of thing. That's actually terrifying, right? That means that like your everyday activities that you're engaged in on these like social media platforms, which really to any normal person would have no relationship whatsoever to like your health status, right? With enough examples and like really powerful learning methods, end up being pretty good predictors, right? Like, that's a different, but I think even more troubling problem with the way of using easily accessible data to build any kind of possible model. And like that, as far as I know, is like definitely not a conversation that happens. Like, entire communities of computer science are built around the fact that like there's now social media data available to do this work. And I think like, to me, that's like something that we should be talking about way, way more, and explaining that like, there's reasons beyond robustness to actually focus on other kinds of things to measure, besides the fact that we have this like, easily accessible stuff on social media platforms.
So I just want to say, very grateful for this question and for this discussion. This is super, super good to see it happening. So I will though say one thing, so check out Jessica Vitak, she's at University of Maryland. She published a paper called Beyond the Belmont Principles, which was all about whether IRB is enough, because a lot of these data mining operations that Solon was alluding to, even if they do go to the IRB, they're treated as exempt. Even though there's no explicit consent actually going on, obviously, and people don't actually have real expectation of the kind of research that's going to go on. But I will, I guess, use this, I hope not too selfishly, as a little bit of a plug for the paper I'm going to present on tomorrow. So the paper that me and Misha, who's in the audience here, published is called The Authority of Fair in Machine Learning, and we're trying to bring in a concept for debate, which is, do you have the authority? Are you legitimately entering this space, essentially, to start trying to solve problems? Have you considered potential biases? Have you considered different community perspectives? But very importantly, we try to like break down the considerations of fairness beyond just, is there statistical parity in my data set or something like this, but like, is this machine learning system something that should be made at all? And then maybe after that question, if I made it, did I make it the fair way? And then after I made it, okay, what are the outcomes actually fair? And I think that, like you said, that third question of are the outcomes fair seems to be the only thing we're really focused on, even though there's all these fairness questions embedded, as she really importantly brought up in the provenance of our data, and we don't even actually ask these questions, like, given this problem I want to solve, is there a data set available I can get? We just say, well, there's data available, so I probably can get something useful out of it. So I guess my answer is there are a few people publishing in this space. I think Jessica at University of Maryland's really great on this. I mean, obviously these folks on the panel also have some great things to say in the FAT-ML community, but at least for me, I'm really trying to hopefully insert this concept of debating over authority, and when we have, as engineers, the authority to enter people's lives in this way, and have we derived that authority legitimately or illegitimately, and having debates over that legitimacy, I think, is really important. So.
Hello? Okay. I was hearing, and I think what you are saying is great, and you are thinking more about education, self-regulation. I was thinking more that maybe we need someone or some organization to regulate this, not to every step, but maybe some common ground, maybe some standard or to give some certification that also incentive companies to follow like a certain regulated body. Why? Because this ethics thing is very subjective. It's your personal values. So if in a company they have different values and another company, it's going to be very hard to get to a consensus like an agreement. And I think we should propose that, to have like maybe some organization to work on that, and to hopefully set first standard for some of the applications that we have in machine learning.
So I guess I'll comment on this in that, I 100% agree we need to be coming up with some higher professional standards as to who can do this work or what does it mean. I mean, I think that there's you talked about common ground, and I think of it as, well, we have the lay public who's actually out there using the things that we make and as technologists, and then we have technologists that are in their own little social enterprise making decisions about what kinds of things they're going to make. And how do we actually create a space where those two people can come together and meaningfully talk about these very subjective aspects of it? And so I definitely am thinking about that problem, and maybe at the end of this panel I'm going to talk a little bit about what my next goals are, which actually have to do with just this. So something I've been thinking about is whether or not we could create some kind of meaningful representation of what considerations went into some particular company's process to create a tool or a product, and how could we simply show people, so this product was not made using any data that wasn't explicitly opted into or something like this, or this product was not, I mean, this is obviously very idealistic, but I mean, in some ways we are talking about something that is an ideal to strive for, right? It's like, how do we make this professional community a little bit more aware? Whether do we do it as a certification? Do we have data science certifications and say, I'm certified to data mine fairly or something like this? Or to me, I think a very interesting approach, because learning more and more from the lay public, even if they don't understand machine learning, there are some intuitions around like, wait, so they use what data to train this? Or, oh wait, they're trying to target what about me exactly? And I think that if we had basically during the opt-in part of when you sign up for a service, some kind of like badge that shows by this nonprofit organization or this external party has reviewed this and it meets these standards, and developing a consensus around what those standards could be, and educating the public on, be on the lookout for these things. And if you don't like certain things, don't sign up for the services that don't have these standards. I mean, this is, again, I'm speaking a little bit idealistically, I very much realize that, but I do think it is something to strive towards, which is, could we come up with a list of standards, and then could we create some external parties that could enforce those standards, or at least interpret those standards on things, and then let the public kind of choose in a meaningful way who they want to give their data to, and which things they want to opt into and which not. And obviously top-down regulation is another way to do all this. In the current moment, I might not be so hopeful for that, so I'm kind of like hoping that from the bottom up we can create some of these standards. So anyways, that's one of my thoughts. I think creating some kind of like point of contact between what the technicians did and what the public or the person who's about to click through and become part of something, I think if we can create something in that moment that better represents the connection or a negotiation between what am I actually expecting here, and what did the technologist try to do here, and does this actually fit my expectations, so people can meaningfully steer away. I think that would be a really good thing to strive for, and my simple off-the-cuff thing is like maybe some kind of badge or way of representing that that becomes standard practice, and then companies who don't opt into letting these third parties look at their models at all, maybe they hopefully get like actually disincentivized for users and things like that. So anyways.
So I'll just quickly reflect on existing regulations. So in the United States, there is no sort of omnibus privacy law, which means that as for questions related to privacy, it's a much more difficult challenge in the United States. In other countries, and in particular in Europe, as was sort of mentioned earlier, there's very, very developed privacy law, which will significantly constrain and govern how people can actually use these techniques. And generally, the European model is one that's replicated in other countries. Enforcement is quite weak in Europe itself, and even weaker in other jurisdictions. But it's all to say that if you're operating pretty much anywhere except the United States, there are existing rules that actually like structure and govern a fair amount of the activity that you folks in this community are engaged in. As it comes to questions of discrimination, however, there are existing laws in the United States that are very well developed. Discrimination law is sectoral, so it applies to particular kinds of decisions. You wouldn't be surprised what they are. They're things like employment decisions, credit decisions, housing, sometimes education. I'm gonna have to get the whole list. Any event, laws apply in those cases. And in principle, they should be up to the task of actually making sure that even when we rely on machine learning, that those decisions can't be discriminatory. But the work I was mentioned that I've been involved in earlier actually shows that there are some really serious weaknesses with existing law, in part because the way that a lot of these tools are assessed as to their fairness, as to their non-discrimination, is to just say, like, were they validated, right? And the problem here is that, as I was also mentioning, like, many times validation can be misleading. It can say like, yeah, this does a perfectly great job, but the problem is that you've actually had encoded bias in the training data. And so to the extent that our standards as they exist in discrimination law just depend on validation, and the people who are going to evaluate those claims are not sufficiently technically expert to challenge them, then existing law can actually be pretty weak. So all this leads me to think that like a lot of the technical work that is now being done to explain how exactly these tools can nevertheless be discriminatory and how we can actually force them to comply with certain notions of fairness, like really needs to be explained very well to regulators so that existing laws can actually be applied effectively. And I think that is the main challenge. Rather than having to necessarily develop totally new law, I think we can empower existing regulators who frankly are very interested. I've talked to pretty much every federal regulator who's interested in these questions. They want to understand these problems. They want to be able to do something about it. So the challenge as far as I see it is just actually making sure that the people who are in a position to apply existing laws have the tools and knowledge to do so.
Yeah, and I want to echo something I said before as well, that I think it also goes through education. Like, I think the top-down effort of standardization and regulation is definitely very important, but also bringing into the classroom like these ideas, making sure that data scientists, the future data scientists, are empowered to understand like these issues of fairness. Of course, there's a lot of research on this, and our definitions and our methods will evolve over time, but make sure that people are learning about them. And also, and you create this feeling of like, what is, in the same way you have an ethical doctor, like you can also have, a data scientist should also follow a guide of ethics, and that starts really in the classroom. And making sure what are the potential like disparate impacts of the systems that we build. And And maybe even encouraging people to stand up, you know, and when they see some kind of obvious malpractice within their company or within their work setting, for them to speak up for that. So I also think a lot of this effort will go through individual training and through curricular reform and talking about what concepts are we teaching to data practitioners.
I think Salam said everything I wanted to say, so.
I think the union of all three, four of you now has said it.
I think we have time for one more question.
This is kind of a long question, but what sort of role does psychology play in your studies? So both for the researcher and for the subject. So for example, as you guys mentioned a couple times, people do what's convenient for them, like the courtroom data, which comes easy, or any data that comes easy. And then also, for the subjects, like people will see what they want to see. So even with the Facebook data, when you have the option to do see more diverse things, people are going to try and opt to see just things they want to see. So I kind of want to figure out what role does this play in your research?
Sorry.
Yep.
I'm happy to pick up psychology.
Yeah. Oh, I'll say something quickly.
All right, okay.
If you have it. No, go ahead.
Oh yeah, I just forgot what I was gonna say. Give me a second. Does someone else want to say something while I try to remember?
Yes, okay, wait.
So I think that a couple things that kind of answer this question. It's obviously very difficult because we're talking about something that's like embedded in people, and even if we measure it, then we have these questions, as I think Solon had brought up before, of then do we manipulate people towards more and more? Oh, look at more and more diversity, and oh, we see you're going away from it, so we push you even further or something. I don't know whether manipulation effects are the right way to do it, but I'll start with so in my research, one psychological thing we're trying to measure to figure out how to potentially warn technicians about at least some of these biases that go into what we're doing. So not user focused, which I think your question was a little bit both, a little bit where's the psychology in our field and where's the psychology on the users. So we're measuring risk perceptions. So looking at what risks people actually believe are the most worrying on them or for society, specifically with emerging data technologies is the focus that we're trying to go on. And I think actually we're finding some really fruitful and interesting things in there, such as basically people seem willing to accept risk more once they believe it's voluntary. And I think in some ways, some of the things we do with using social media data, we're trying to convince people, well, this is voluntary, you opted into this. And I think that even with psychological effects of people trying to potentially avoid certain things and us not being able to potentially actually get people to do what we think is the good thing or whatever, we also though could measure psychological attributes of people to try to figure out, well, what is their values, where is value correspondence happening between a certain audience, and then maybe leverage that to actually potentially bring out factors that maybe everyone is a little bit concerned about having something involuntarily done to them. So maybe we can use that as a possible advantage, to okay, well, you're avoiding this thing and you guys are avoiding this thing, but if we're potentially smart about how we measure these people, we can say, oh, but you both care about this thing, and maybe utilize that. But also, we do it mostly as a reflection for researchers so that we can actually say, okay, well, this, whether or not it's true or not, this is the kind of stuff people are scared about or worried about, and so maybe you should be aware of that, or maybe you should communicate whether you're doing this or not. So I do think that psychological metrics or asking people about their perceptions is a good way for us as practitioners to reflect on how we're communicating. But I also will point you towards, and I apologize, I'll get the name and catch you after the panel. There was some people doing some really interesting work. I mentioned at CVPR, I saw some people actually doing studies where they were showing people visual data and asking people what they were comfortable with, and basically trying to figure out people's psychological profiles of what they're actually comfortable with sharing, and then whether or not a particular research project violates that kind of comfort level. And what the outcome of their project was, which I think maybe leads to something more fruitful and individual in this case of some of the stuff you're asking, is they were trying to make privacy assistance where I can give a little tool that pre-processes my what I'm about to post on social media and says, okay, given your psychological profile of what you're worried about privacy-wise or what you're worried that is sensitive, here's what you're about to post, here's potentially what's in it, and this gets to some of the stuff I was asking the panel about earlier. And it basically empowers the user to figure out, well, where do I stand? How do I feel about all of this? And then self-reflect on what way do I want to participate? Am I okay with going a little bit out of my comfort zone? Am I about to go out of my comfort zone given what's going on? And I guess that's, I think that is actually like an interesting area to start thinking about, is since we don't know what biases people are bringing to the table who come to the content that we create or whatever, and we're trying to maybe, if we are ethical and we're trying to motivate people to do something that's more positive, maybe we can also potentially let people express their own risk perceptions, their own perceptions of what they want or what they want to do, and then essentially allow us to help them optimize their content given what their value system is, but also then using those perceptions, we can potentially create systems that have more correspondence across audience values and things like this. So I don't know if I fully answered your question, it's very difficult, but yeah, but I appreciate it, thank you.
I'll try to be quick and just add that actually there's a long history actually within KDD of thinking about how people actually use the models we develop. And in a way, there's sort of like a latent psychological question around that too. In fact, what Bert was mentioning earlier in the panel, I think gets to the heart of that, right? Which is people aren't willing often to use models that they don't really have intuitions about, that they don't understand. And there's a little bit of research, I mean, quite a bit if you go back quite far actually, really trying to understand like what does it take to actually get people to use these predictions. And I think some of that work is certainly informed by psychology, and I imagine there's a lot of opportunity there to do more work to really understand how our models inform human decision making. And I'll even relate it to this question around criminal justice. So there was a case in Wisconsin where a defendant challenged the use of a prediction tool that informed his sentence. And the argument was that they couldn't actually challenge the tool because it was proprietary and secret. And ultimately this went to the Supreme Court of Wisconsin, and the decision there was basically something like, well, judges are allowed to use this tool so long as they understand that it's fallible, and it should inform the decision, not be the only basis upon which they make their decision, right? This, if we go to observe empirically how the tool is used, can be very revealing from like a psychological perspective. Because what I imagine is likely to happen is something like this. When the prediction confirms the judge's existing attitude, they're going to rely on it. And when it's something that they disagree with, they'll overrule it, right? And so I think there's actually a lot of opportunity here to focus on empirically how humans are making decisions when they are supposed to be informed by the tools that we're developing. So.
You have one more?
I just have one thing to say. So I really agree with this point. I think that one really key point is when people are using models, they always kind of think that there is just one true model. And that's just not the case. There's always like a pool of equally good models, and just showing them two of them kind of dismisses this myth that, there is this one true thing and this is the underlying actual thing that's working. And I also think, it touches upon Flavio's point, just because like the way we teach statistics, we always say like, oh, under these assumptions, there's only one possible true model, and these are like the MLE estimates and da-da-da. Like in the real world, this isn't really true, but it really does affect the way that people use our models and what they try to extract out of them.
So I originally said I didn't have anything to say, but Sloan reminded me of something regarding sex. So I think actually, the question of judges not using the models is really interesting, and also how what they are displayed affects their decision-making process. So as far as I don't actually know exactly how much they rely on them or not. I would believe your explanation for how they use them. But one of the things that I think is a really interesting question that does revolve around the sort of psychology of these models is the output, right? So you could show the judge something like, this person's high risk and this person's low risk. How do they interpret what high risk means? In a lot of cases, when they see a label that says high risk or not recommended or something that sounds very scary, or red on the matrix, right? If you dig down into the numbers, you'll see something like, this person has maybe a 20% chance of failure to or something like on that order of magnitude. So you'd think, does that really warrant high risk? Does that really warrant red or not recommended? How would they interpret that? Would they think it's really 20%, or when they see high, would they think it's more like 90% or something? I don't actually know what the answer to that question is. And so I think there's a lot of research to be done on.
There was a really interesting visualization, I can look and find it, that they gave people a bunch of those labels, like very high, medium, probably, almost certainly, and they had people guess or say what number they think that implies, and it's all over the spectrum. Like there's no agreement about how people perceive those different numbers.
And I'm sure it's context specific too, because what
Yeah.
would be considered a high risk for somebody to murder somebody, right? Like I would have a much lower threshold for what high means. And so
Right.
in the past I've said something like, why don't we just show them the number, like what your predicted number is? I said, well, judges don't understand what percent means, so we can't do that. So.
All right, so we've had a very exciting discussion. The lunch is here, so we want to ask the final question. So, what, one thing you really want the students to take away from this discussion, or you want them to know if they are interested in this field and want to get involved? So what's your final thing you want to add? And I'll go through the slides you guys made to start, but obviously add what we've discussed today. So, what's your one last thing you want to make sure everyone takes away?
Yeah, I think that being very aware of when you create a system that there is a way the problem's being framed, like whose problem are you trying to solve, what is the ideal solution to the problem, what is the functional logic that allows us to solve this problem, and just being aware that there's these norms in there. I think all of you are, it seems, very aware of the fact that there's these norms embedded in the way we frame the problem, but the problem framing ultimately decides what data we're probably going to think is actually useful, or maybe the panel challenged that today, maybe it's just what's available or whatever you can get your hands on, which is probably the case, but maybe pushing back and actually considering ahead of doing any technical work, considering what your problem framing is and what potentially the ideal data set is, and whether that's you pushing your PI or whether that's you pushing your company a little bit to be like, hey, we're about to start this operation, or this, we're going to try to create this new feature, and here's how I'm seeing the problem framed right now. Is there a way that we could frame it a bit more, this way or that way? I mean, I assume a lot of you guys will be the creative minds in the room that sees the other framing that potentially isn't that good. And so I think that getting really into that idea of like seeing the biases in problem framing and being able to elevate it. Yeah, that's probably my biggest takeaway point.
And these slides are going to be shared, so you don't have to worry about taking pictures while it's up. So their contact information, you'll get it at the end of the day.
Yeah, so I think my advice is just maybe target it to more graduate students, PhD students, but I would just advise you to collaborate with people outside of machine learning or statistics, go and work in applied domains. I think that a lot of time people kind of look at this as like, oh, these are easy problems, but a lot of time they're not, especially when you try to deal with these problems directly instead of trying to just apply what you created. And in doing this, I think you really get a good view on how your models are being used by practitioners, and the kind of pain points that they face every day, like things like software, coding, parameter tuning. These are all things that at the end of the day affect the way the models are actually being built, and will probably affect the decisions that are being created for them.
I think think carefully about how your data was collected and if it encodes biases and whether what you're building could perpetuate those biases.
Yeah, I have a standard takeaway, but maybe what I'll add at the moment here is that, I'm sure you're all aware that this is a very hot field. The discipline of machine learning is the most active area in computer science. There's lots of exciting job prospects. I'll make a pitch here to say that actually making these sets of issues part of what you work on is actually probably also something that's useful professionally. And I don't say that in a self-serving way, in the sense that I want this community to grow. But frankly, it will actually, I think, reflect well on you that among having expertise in the standard set of things in machine learning and data mining, you also have thought through and have developed ways to like tackle these issues, which lots of companies, including the giant companies, I worked for Microsoft this past year, really do think about, right? Like this is like a serious pressing concern, and although there might not be regulation that's there like breathing down their neck, like they care and want to do something about this, and so I think this can also just be something that helps distinguish you in the market.
Yeah, and for me, I guess what I want to say, especially for the PhD students in the room, is don't forget about the theory as well. Like use your practice as a source for meaningful theory. If you're doing data science, don't forget the science in data science. You know, don't forget to look at what metrics are being used. Try to understand what's behind the model that you're adopting, and don't shy away from the math behind it, because one of the weapons we have in our arsenal is exactly this. You know, it's this precision that we can bring to this discussion. On the other hand, theory without talking with practitioners, without talking with social scientists, is completely meaningless, at least from my opinion. So use this theory as a design driver for meaningful practice, and try to generalize your methodology, right? Make sure that what you're doing won't apply, and this is easier said than done, but won't apply just to this specific data set in this specific case, but see if it is actually a broader thing that you're discovering or that you can apply. And being a little bit cheesy here, also be brave, you know, because these are topics, even though it's a very hot area and there's a growing concern in ethics and fairness in machine learning, this is not necessarily aligned with your future project manager's interests or even with your current PhD advisor's interests. So be brave, challenge them, question the assumptions and the data that you're using, and make sure to bring these questions on ethics and fairness into your work and into your workflow, into your lab, or eventually into your office. So, yeah.
All right. Great. Thank you guys for having a great panel discussion. And you guys have a workshop tomorrow. Do you want to give a quick shout out about the workshop tomorrow so that if students are interested?
Yeah, so there's this fairness, accountability, and transparency in machine learning workshop tomorrow. I should be able to find the room. It's on, like, I mean, if you look at the schedule, you'll see that it's one of the workshops listed tomorrow. It's an all-day workshop, and we have two keynote speakers, some invited talks, and then a bunch of posters. So if you're interested in this, you can really get a sense of the state of the art. There'll be a large number of people. We've like purposely tried to keep this big. It's in Suite 202, so just downstairs, and it's from like 8:15 until about 5. So stop by at any point. Especially, I encourage you during the lunch break. We'll have a great poster session. So thanks.
All right. Thank you. Hopefully we can stay engaged and thank our panelists. And I asked that last question with plenty of time because I assumed they'd go over what I said they should do, but they didn't. So we're actually at time for lunch a little bit early. And after lunch is going to be tutorials. So if you haven't, they're going to be hands-on ideally. So if you haven't taken the steps we asked you to, we recommend you can do that during lunch. We've got plenty of time, and our panelists are welcome to stay and eat and continue the discussion. And have a great lunch.